Hi, myself Devananda Rao, Associate Professor working in the Department of CSC, MLR Institute of Technology. I am teaching Automata and Compiler Design. So, the overview of the topic is grammars and types of grammars. In 1959, Noam Chomsky tried to give a mathematical definition for the grammars. The motivation was to give a mathematical definition for the grammars for English sentences. He defined 4 types of grammars. They are type 0, type 1, type 2 and type 3. Let us understand how the grammar will generate a sentence. I will consider a sentence in English language. The man ate the fruit. This is the sentence I am going to derive. Here S is the sentence symbol. The sentence symbol will derive noun phrase 1, verb phrase. Noun phrase 1 derives article and noun 1. Article derives the, noun 1 derives man. Verb phrase derives verb and noun phrase 2. Verb derives 8, noun phrase 2 derives article and noun 2. Article derives the, noun 2 derives fruit. See, this is the syntax tree. This is syntax tree or parse tree. Syntax tree or parse tree. See, in this tree we have internal nodes and leaf nodes and starting symbol. S is the starting symbol. Any derivation starts with start symbol. The internal nodes are called syntactic categories. The internal nodes are called syntactic categories, also called as non-terminals. The internal nodes are called non-terminals. Non-terminals represented by uppercase letters of English alphabet. The leaf nodes are called words, also called as terminal symbols. Terminal symbols. Important point is the internal nodes can be rewritten. The leaf nodes cannot be rewritten. Internal nodes can be rewritten means, see, noun phrase 1 is rewritten as article and noun 1. Verb phrase can be rewritten as verb and noun phrase 2. But leaf nodes, that is called terminal nodes, cannot be rewritten. Always the derivation starts with the start symbol. S is the sentence symbol. In this, these are the rules of the grammar. Rules. The start symbol S derives noun phrase 1 and verb phrase. Noun phrase 1 derives article and noun 1. Article derives the, noun 1 derives man. Verb phrase derives verb and noun phrase 2. Verb derives 8. Noun phrase 2 derives article and noun 2. Noun 2 derives fruit. So, these are called rules. Rules of the grammar. Rules of the grammar. See, by using rules of the grammar, we can derive a sentence. How we can derive the sentence? We can see. Derivation always starts with the start symbol S. S derives noun phrase 1 and verb phrase. In the next step, each and every step, we will replace only one non-terminal, only one syntactic category. Noun phrase 1 derives article and noun 1. Article derives the, noun 1 derives man. Noun 1 verb phrase, in the second step we will keep verb phrase as it is. Noun 1 derives man and verb phrase as it is. In the third step, the man, verb phrase derives verb and noun phrase 2. In the next step, the man ate noun phrase 2. In the next step, the man ate, noun phrase 2 derives article and noun 2. In the next step, the man ate the noun 2. The man ate the fruit. This is called derivation. This is called derivation. Derivation of the sentence. In each and every in each and every step only one non-terminal can be replaced. Coming to the types of grammars, we have 4 types of grammars. First type is type 0 grammar, also called as phrase structured grammar. In this, the grammar having 4 tuple. They are grammar G is equals to VTPS. V is set of non-terminals. T is set of terminals. P is set of production rules. S is start symbol. Grammar is defined as 4 tuple. Type 0 grammar. Type 0 grammar, the rules will be in the form U derives V. Left hand side is U, right hand side is V. So, left hand side we should contain at least one non-terminal. At least one non-terminal. Left hand side should have at least one non-terminal. Right hand side containing combination of terminals and non-terminals. In this example, S derives ACAB. S derives ACAB. A, C, B and S are non-terminals. A is a terminal. Right hand side we have combination of terminals and non-terminals. Non-terminals represented by uppercase letters, terminals represented by lowercase letters. Second rule, B, C. B is a non-terminal, C is a terminal, derives ACB. Right hand side we have combination of terminals and non-terminals, but left hand side we should have at least one non-terminal. B is a non-terminal. Here S is a non-terminal. Third rule having 2 non-terminals, C and B. Fourth rule having one terminal, one non-terminal. So, left hand side of the rule should contain at least one non-terminal. Right hand side may contain any number of terminals and non-terminals, string of terminals and non-terminals. This is called type 0 grammar, also called as phrase structured grammar. Next, type 1 grammar. In this type 1 grammar, the rules will be in the form U derives V and length of U should be less than or equals to length of V. The length of U should be less than or equals to length of V. And also one more important thing is right hand side RHS of the production, this is RHS of the production, should not contain epsilon. Should not contain epsilon. Left hand side should contain at least one non-terminal. At least one non-terminal. Left hand side should contain at least one non-terminal like this S, T and A. Right hand side combination of terminals and non-terminals, but should not contain epsilon. And one more important thing is length of left hand side should be less than or equal to length of right hand side. This is type 1 grammar. Type 2 grammar is a context free grammar. The rules will be in the form U derives V or A derives alpha. A is a single non-terminal. Alpha is a total alphabet, that is combination of terminals and non-terminals. Left hand side exactly one non-terminal. Not more than one non-terminal. RHS should contain terminals and non-terminals. Epsilon may also be present. This is type 2 grammar. Type 3 grammar. Type 3 grammars are regular grammars. The rules will be in the form A derives alpha, B or A derives beta. B is a non-terminal. Alpha is a string of terminals. Alpha is string of terminals. B is a single non-terminal. Here A derives beta. Beta is string. Epsilon may be present or string of terminals. Beta is string of terminals. See, left hand side single non-terminal. Right hand side is having string of terminals followed by last symbol must be non-terminal. Here non-terminal. Epsilon may be present. This is type 3 grammars. Type 0, type 1, type 2, type 3 grammars. Next, consider this example. This is type 2 grammar. Type 2 grammar. type 2 grammar or CFG grammar, context free grammar, where G is equal to NTPS or VTPS, non-terminals are S and A, terminal symbols are A, B, C, the productions are given in the form S derives ASC, S derives AAC, A derives B. This grammar will generate strings A power n, B, C power n. That is n number of A's followed by B followed by n number of C's. Here the number of A's and number of C's must be equal. The center symbol is B. For example, if you take this A, B, C, C, we can generate this string by using these rules. First, I will take first rule, S derives A, S, C. In the second step, I will take rule 2, S is replaced by A, C. In the third step, A is replaced by B. So, A, B, C, C is generated. Like that, we can generate A power n, B, C power n. The language generated by this grammar is A power n, B, C power n such that n is greater than or equals to 1. Thank you.